I want to thank everyone for joining us today for our presentation on the 2022 Chicago Energy Transformation Code. A couple of quick notes before we get started. If you do have questions for us during the presentation, please use the Q&A pane to ask those questions. It helps us keep track of what we've been asked and answered. And if we need to follow up with you later, it provides that information to us so that we can reach you more easily. Before we get into our presentation, we do have Eric Klinner and Juanita Garcia here with us today to say a few opening words. Eric, you want to say hi to everyone?
Thank you. My name is Eric Klinner, and I'm the Managing Director of AIA Illinois. We're excited with our continued partnership here with CDAC and the Illinois Green Alliance to provide these building energy education webinars. This is the second of the three in the series, and I look forward to all of you signing up for the third one. Have a great day.
Thank you, Eric. Juanita, you want to say a few words?
Sure. Thank you, Sean. So my name is Juanita Garcia. I'm a senior project manager with Pepper Construction and also have the pleasure of serving on the board of directors for the Illinois Green Alliance. For those of you that might not be familiar, Illinois Green Alliance is a member-driven nonprofit that works to promote green buildings and sustainable communities for all. Our vision is all about bringing net zero technology and design best practices to every building in Illinois through professional education, policy so we can scale the impact of high performance design, and community service projects to show that high performance and net zero building techniques are affordable and feasible anywhere in Illinois and in any building type. Every year we host more than 75 education events, building tours, and community service engagement opportunities like the Illinois Green Schools Project. I hope you'll consider getting involved either by attending an upcoming event or by lending your time or expertise to one of our events or programs. To learn more about upcoming education programs, I encourage you to visit our website at illinoisgreenalliance.org. And to deliver so many events every year, it is only possible thanks to partnerships like this one. So thank you to CDAC and AIA Illinois for hosting this event and partnering with us on this program.
All right, thank you, Juanita. Okay, so joining me today is Robert Schlorf, one of the senior energy engineers in our office. My name is Sean Maurer. I'm a professional engineer and technical director here at CDAC. Training today is provided by, we are a preferred education provider with the International Code Council, so continuing education credits are available for that program. We also provide 1.5 learning units for AIA continuing education. At the completion of this webinar, you'll get an email with a certificate of attendance, and we'll also turn in those continuing education hours for you. So content we're going to cover today, kind of an overview of the Chicago Energy Transformation Code updates from the previous 2019 Chicago Energy Conservation Code. We're going to describe some of the key changes that have occurred between the two, summarize the most significant Energy Transformation Code compliance issues in commercial and residential provisions, and help understand how to comply with the updated transformation code for commercial and residential buildings. A little bit about CDAC before we get going. We are an applied research program at the University of Illinois, and we work to assist buildings and communities in achieving energy efficiency, saving money, and becoming more sustainable. Our overall mission is to help reduce the footprint of Illinois and beyond, both energy and carbon related. As part of that objective, we host regular training webinars for energy code compliance and education. We also host this building energy education series for architects. So thank you all for joining us. And we hope you can join us for our third presentation in this series on May 18th, where we'll be reviewing both the Illinois Energy Conservation Code, the Illinois Stretch Codes, and the Transformation Code, and kind of how they all interact with each other. As an energy code training provider for the state of Illinois, we do also provide technical support through our website. You can reach us at energycode@illinois.edu or call us at a 1-800 number if you have a quick question that you can get a quick answer for. We do prefer that you send us an email. It gives us a time to fully understand your question, pass that around amongst all of us here at the office that work on the energy code programs, and get you the most detailed answer that we can. We also host a number of other resources on our website, including our past workshops and webinars, some self-paced online courses, and direct links to the Energy Conservation Code, the Chicago Energy Transformation Code. And once the state has adopted amendments, we'll also have links to the state amendments, the Stretch Energy Code, all that information. We also have on our website some energy certification energy certificates that'll go on the electrical panels in commercial and electrical buildings, and some checklists that you can use for verifying energy code compliance. And you can find those at the checklist link at our website. So again, a little bit of overview what we're going to get through today, a little bit of background on where the Energy Transformation Code has been, how we've got to where we are, and where we plan to go in the future. We'll go over the commercial provisions, then the residential provisions, and a little bit of information about different compliance options for how to comply with the Chicago Energy Transformation Code. Just getting a bit into the background. In 2001, Chicago's first energy efficient construction requirements were approved and have been regularly strengthened on kind of the same 3-year cycle that the IECC follows and ASHRAE follows. So once the IECC is out and published, the state will then go through an approval process, working on the amendments, and usually within a year of the IECC being published, the state's within that next summer usually adopts the amendments. This year has been a bit special, so it's taking a little bit longer on the approval process, but we do expect by summer that the state of Illinois will be on the 2021 IECC. However, Chicago has approved the 2022 Chicago Energy Transformation Code as of November of last year, and so permits after that date must comply with the Chicago Energy Transformation Code. The advancements of the codes help support Chicago's energy and climate commitments. It follows with the Climate Crisis Resolution from February 2022 and the Chicago Climate Action Plan. The goal for the state is to reduce overall carbon footprint and emissions by 62% from 2017 levels. The energy codes are a good way to help ensure that new buildings that are constructed and renovated existing buildings are reducing their energy consumption as much as possible. So why the update from the Chicago Energy Conservation Code like it was in the last cycle to now the Transformation Code? The key thing here is that Chicago is looking forward towards electrification and application of renewable energy technologies to buildings to help offset carbon emissions. So with that focus on energy efficiency plus clean energy, that equals energy transformation. And so that's why in the current code cycle, they've renamed that to the Chicago Energy Transformation Code. Here at CDAC, we like to recommend to everyone that first you got to conserve, then you will apply renewables to your projects. If you don't conserve energy first, you're going to be spending a lot more money on renewables and consuming more resources to provide those renewables to buildings. So conserve first, get your energy consumption as low as possible, and then start applying renewable energy technologies to those facilities. Energy conservation requirements are proven to help reduce energy consumption. So based on analysis of upgrades from the 2018 IECC to the 2021 IECC, residential buildings are expected to reduce their energy consumption by 9.4%, where commercial buildings are expected to reduce their consumption by about 5%. The Chicago Energy Transformation Code does have some amendments to it that change it from the base IECC code, but for the most part, those amendments are involved with solar readiness and applicability to electric vehicle readiness as well. And so these general savings numbers between the 2019 Chicago Energy Conservation Code updating to the Transformation Code in general do apply. So we would expect that between those two different codes, commercial buildings will see about that 9.4% reduction in energy, or sorry, the residential buildings will see that 9.4%, and commercial buildings will see that 5% reduction. So before we move on, start talking about the commercial provisions, we do have a quick Q&A poll here. We'll launch that. Our first question, what is the target carbon reduction from 2017 levels in the Chicago Climate Action Plan? Was it 41%, 55%, 62%, or 74%? And then how much has the Chicago Energy Code improved since the 2001 Chicago Energy Code? Is it about 20%, 40%, 50%, or 60%? And we did have a request to enable the chat. The chat is enabled now. But again, if you do have questions for us as we proceed, please use that Q&A window so that we can keep track of those questions and answers. Okay, it looks like most people have their answers in, so we'll go ahead and share the results. So it looks like most people caught on the first one. The Chicago Climate Action Plan aims to reduce carbon emissions by 62%. Is the correct answer there. And then the Chicago Energy Code since 2001 to current has improved by about 40%. So most people caught that as well. So I will turn it over to Robert now to start going over some of our commercial provisions.
All right, thank you, Sean. All right, so as Sean mentioned, the 2019 Chicago Energy Conservation Code was based on the 2018 IECC as the model code. The 2022 Chicago Energy Transformation Code is based on the model code 2021 IECC. But also adds a number of additional Chicago-specific requirements. Those requirements are centered around solar-ready roof requirements, electrification-ready residence requirements, balcony and parapet insulation, a prohibition on gas-fired lighting, new gas-fired lighting, roof reflectance requirements, that were carried over from the Chicago Building Code, as well as electric vehicle supply equipment ready requirements. Now, the roof reflectance requirements are typically removed by Illinois amendments within the state adopted energy code. That's generally because the solar reflectance requirements are only applicable to climate zone 0 through 3 anyway. The Chicago Energy Transformation Code has added solar reflectance requirements back in for climate zone 5. We'll talk about those a little bit further on. So a little bit more about the model code. So the model code again is the 2021 International Energy Conservation Code, and that is being adopted as the model code without any weakening amendments. There are additional requirements, as I just mentioned, as well as a couple additional pathways. So first, there's a couple additional compliance pathways that are allowed within the Chicago Transformation Code, and those are Passive House Institute certification, as well as National Green Building Standards certification. If a project or if your project complies and receives certification through either of those entities, you have no other additional requirements through the Chicago Energy Transformation Code. Your building complies. As mentioned earlier, there is a ban on new gas lighting, and this is specifically new gas lighting. It is not does not have any effect on existing gas lighting, but is a ban on any new gas lighting. The reason for that being that gas-fired lighting fixtures produce a significant amount of waste heat, as well as exhaust fumes and direct emissions, and so we want to not allow those devices to be installed anymore. There's also additional thermal break requirements for balconies and parapets, electrification ready requirements, and solar ready roof requirements that both should make new buildings within Chicago more prepared for the transition to renewable energy. As Sean was mentioning earlier, as we continue to try to push the national grid towards more renewable energy, these requirements here should help prepare new buildings within the Chicago area for that transition, make it easier and make it more cost effective in the future. So real quick, talk about the difference between commercial and residential. We're talking about commercial requirements at the moment, but the Chicago Energy Transformation Code is set up the same way as the model IECC code, where there is a commercial section and a residential section. Both of these sections contain very similar chapter sections within it that correlate to the IECC requirements. So chapter 4 is where you would typically find your envelope information, as well as your systems information. And then chapter 5 references existing buildings. There's been an addition to both of these sections. That's chapter 6 that contains the Chicago specific requirements. If those requirements are related to other requirements within previous sections, they will also be referenced there, but chapter 6 contains all of the Chicago specific requirements in one location for you there. Now, how do you define which path or which section you follow for your project? That's determined based on the definition of a residential versus a commercial building. And under the Chicago Energy Transformation Code, a residential building is any building up to 4 stories tall that contains non-transient residential units or residential spaces, non-transient residential spaces up to 4 stories. If that applies to your project, you go into section R and follow those requirements. Any other building, you move to section C and follow the commercial requirements. So here we have an excerpt from the installation component minimum R value tables. So we've highlighted the areas there where the installation requirements have been increased over the previous 2019 Chicago Energy Conservation Code. The values shown in white with parentheses there are the original 2019 Conservation Code values. The values shown in black are the new 2022 Transformation Code values. And looking at these, you can see that the roof insulation for attics has been increased some, but then the other improvements here are primarily continuous insulation improvements, requiring more continuous insulation than the previous code cycle. Here we've pulled out the insulation requirements for floors from the R value table, and this is just for climate zone 5 as with the last slide. So again, we see an increase in the continuous insulation requirements for both mass floors and unheated slab floors. One note here is that for heated slab on grade construction, insulation is permitted to stop at the bottom edge, the bottom slab of the slab edge. The interpretation here is that best practice for any heated slab is to wrap the heated slab, both bottom and perimeter edges, with insulation. This is in order to create a thermal break between that heated slab and the rest of the surrounding structure. And then another note here, another note here is that the requirements for doors that used to be contained in the 2019 R value table have now been moved to the U factor table in the 2022 Transformation Code. So moving on to the U factor tables, again, we've pulled out the requirements for roofs and walls in climate zone 5 here. And again, we have improvements in these U factor requirements that mirror the improvements within the R value table. Same noting system goes here, where green highlights represent where values have been improved, and the white text represents the original 2019 Conservation Code values. And here we have pulled out the floors and doors from the U factor tables for climate zone 5. One note here, change in the heated slab F factor listings. These have been corrected in the 2022 Transformation Code to more closely match ASHRAE 90.1 Appendix A. So not necessarily an improvement, but bringing the two codes in closer alignment, which is something that's happening in between the IECC and ASHRAE 90.1 as well. So another instance of trying to bring multiple energy codes a little bit closer in alignment there. And then our second note here is that non-swinging doors, as I mentioned earlier, have been moved from the 2019 R value table and are now located in the U factor table here. The requirements for those doors have been slightly relaxed. The main reason for this switch is that non-swinging doors typically are overhead doors or revolving doors. By using a U factor to determine the requirements for these doors, we can get a better overall sense of the assembly's performance, not just the insulated panels that might be a part of that door, but rather the entire door's assembly performance. That's why this has been moved from the R value table to the U factor table. So moving on to balconies and parapets. So as I mentioned earlier, there has been a new requirement added onto the model code for the Chicago Transformation Code is to limit thermal bridging through balconies and parapets. This applies to new construction with any exterior balconies or parapets that interrupt the building thermal envelope. Now these can be dealt with in two ways. The first way is to install continuous insulation around either the balcony or the parapet. The R value of that continuous insulation must be equal to the adjacent wall that it is interrupting. If the balcony interrupts more than one type of exterior wall with different R values or different insulation levels, the balcony continuous insulation must equal the higher R value of the adjacent wall being interrupted. The other option here, besides continuous insulation, is to incorporate a minimum R3 thermal break at the location where the element penetrates the thermal envelope. So if we look at the bottom photo on the right there, we see a prefabricated structural thermal break that is that's installed, or a rendering of it being installed at a balcony level, or potentially some sort of architectural element there. But that is a prefabricated structural thermal break that can be installed there. And there is an exception to these requirements, that an exception that allows for structural penetrations through that thermal break, as long as they do not exceed 1 square feet or 1 square foot. So that would be penetrations for rebar, post tensioning cables, steel beams, or other steel members that need to break through that thermal break in order to support the balconies beyond. The interpretation here is that that is a maximum of 1 square foot per structural element or penetration through the thermal break. Here we've drawn and isolated some balcony details here that show compliant details on the left and a non-compliant detail on the right. As you can see, it needs to be either continuously wrapped in insulation, as the option up there in the upper left, or applying a thermal break, as in the other two compliant options there. And then moving on to some details here for parapets. So again, we're highlighting compliant versus non-compliant details for parapet installation following these new requirements. We would like to point out that even in a continuously insulated parapet, there is a risk of condensation up within that parapet assembly. This is primarily due to improper or maybe faulty air sealing details at the bottom of that parapet that would allow interior conditioned air to infiltrate that assembly and rise up into that parapet and then cause condensation. So there are a couple ways that you might be able to deal with that. You can either design or carefully consider your air sealing details at the base of the parapet to make sure that that air intrusion into that assembly is not an issue. Although there could be a good argument there that if you're going to that much trouble in terms of trying to keep air from entering that parapet assembly, you might as well just install and detail a thermal break. So there are two options there, but we just want to point out that there could be a risk of condensation, particularly with narrow and tall parapet assemblies where there's just not quite enough insulation there to prevent condensation within that assembly when interior air can get into there. Moving on here to thermal resistance of cold form steel assemblies. So the Chicago Energy Transformation Code has removed the effective R values for steel stud wall assemblies table that is included in the 2021 Energy Conservation Code. This has been replaced with the American Iron and Steel Institute's S250 formulas for cold form steel assemblies. And how that works is the U factors of exterior walls using cold form steel members must be determined in accordance with S250 formulas. Any framing spacing can be used when continuous insulation satisfies the U factor max with no cavity insulation. So if you're satisfying the minimum U factor for your exterior walls with no cavity insulation, you don't need to worry about S250 formulas. If your exterior walls are steel framed at 24 inches on center or 16 inches on center, you move to the next lowest spacing factors, as we're showing there in that graphic to the right. For greater spacing than 24 inches on center or 16 inches on center, you would use the S250 formulas without any modifications. And then if you have a wall assembly or other assembly using steel members that are non-standard steel members, you would use the S250 formula options for non-standard framing members. And the main reason behind this sort of shift here is to really drive home the impact of thermal bridging through steel stud assemblies. It's been shown over and over again, especially if you've ever seen thermal images of a steel stud assembly, that thermal bridging is a significant problem with that method of construction. And these requirements here are trying to limit the impact of the thermal bridging through your exterior assemblies as much as possible. And the hope here is that either this pushes a little bit more towards continuous insulation, as the code values, the tables that we showed previously are also doing, or pushes towards more advanced framing techniques that limit thermal bridging in other ways. But the main component here is that we are trying to eliminate thermal bridging as much as possible through the assembly. Moving on to fenestration, maximum U factor, and solar heat gain coefficient requirements. So there's not much of a difference here between the Chicago Transformation Code and the updated 2021 IECC code. They are pretty much in alignment. There is a little bit of an improvement in the actual required U factor and solar heat gain coefficient values, but the main difference to keep in mind is that solar heat gain coefficient is no longer determined by orientation of that fenestration. It is now determined by whether or not that fenestration is fixed or operable. So this requirement sacrifices some of the potential for cost-benefit trade-offs by using lower performing windows on the north side of a building. But this better accounts for the fact that operable fenestration generally has a much more difficult time with air sealing and being thermally broken than non-operable fenestration. So the difference here is saying that if you have operable fenestration, your solar heat gain coefficient is going to be greater. Because that operable window assembly is a little bit poorer in performance than a fixed window or fixed fenestration would be. Moving on here. So as with the IECC, there is a pathway that would allow you to increase the amount of vertical fenestration on your building. Vertical fenestration can be increased to a maximum of 40% of the above grade wall area when the following requirements are met. So for buildings with no more than 2 stories above grade, at least 50% of the net floor area has to be within a daylight zone. For buildings 3 stories or more above grade, at least 25% of the net floor area must be within a daylight zone. And for both of those, daylight responsive controls must be installed within the daylight zone. And then lastly here, visible transmittance of vertical fenestration shall not be less than 1.1 times the solar heat gain coefficient. There is an exception, but that exception there only applies to that fourth item about visible transmittance, and that exception applies to any fenestration that is outside of the scope of NFRC 200. So NFRC 200 is the standard for determining solar heat gain coefficient for windows, doors, skylights, and curtain walls. Any fenestration that does not use flat glazing cannot use the NFRC 200 methods for determining solar heat gain coefficients. So essentially this is saying that fenestration such as domes, solar tubes, or other contoured glazing do not need to meet that fourth item visible transmittance requirement. And although this is another bit of kind of building science that we like to include here real quickly, is that although the code does allow you to increase the amount of vertical fenestration on the exterior of your building, we highly recommend that you carefully consider the idea of increasing vertical fenestration around the exterior of your building. The main reason that we caution over glazing or increasing glazing in general is that a window is always going to be the weakest point of an exterior assembly. In terms of insulating value, a window will almost never get to the point of an opaque wall assembly in terms of insulation value. So the more vertical fenestration area you have on your building, the more potential thermal weak points you have within the building. Another point here is that if glazing is not properly shaded, you can have significant problems of overheating, dealing with unwanted solar heat gain through those windows, even if they do have coatings on them and such. Once the light gets in the glass and gets into the building, the heat is also into the building, and then you must deal with it one way or another. So although the code does allow for an expansion of vertical fenestration, we recommend thinking carefully about that decision. And then one more requirement here for fenestration. This requirement may be familiar to some of you who are familiar with the state energy code as well. This is a proposed amendment for the upcoming energy code as well, for the upcoming state energy code. This requirement here is for buildings with more east and west fenestration than north-south fenestration. And the essential idea of this requirement is that the glazing on the east and west facades of a building such as this that has more east and west glazing, there'll be a slight penalty put on those east and west fenestration that will essentially those windows need to be higher performing than the ones on the north and south side. And the reason for this is that we want to do our best to compensate for the high heat gains that we see on the east and west facades of a building, especially, morning and afternoon sunlight can be pretty harsh and pretty hot depending on the time of year. And so we want to, if a building has a significant amount of east and west glazing, this requirement here is trying to account for that and trying to make sure that east and west glazing is a little bit higher performing, so that you don't suffer from unwanted heat gains. So how you determine if your project needs to have adjusted solar heat gain coefficients in this way is you follow the given formula there, where you would take the area of the west facade windows times the solar heat gain coefficient of the west facade windows, and that must be less than or equal to the total area of the fenestration around the building times the solar heat gain coefficient given in the code, and then divide by 5. So what this formula breaks down to is essentially the east and west fenestration on a building would need to be about 20% improved over the base code minimum values in terms of performance for solar heat gain coefficient. So again, that's about a 20% improvement for east and west facing windows. And now I believe we have our second poll question here. All right, so question 1, only balconies are required to have thermal breaks in the 2022 Chicago Energy Transformation Code. Parapets are optional. Your choices there are true or false. And then second question, how much does the east-west area weighted solar heat gain coefficient have to be reduced below the total code required area weighted solar heat gain coefficient to comply with the Transformation Code's Fenestration Performance Amendment?
We've had a few questions come in. One is there an ASHRAE compliance path for the Transformation Code? Yes, that's part of the 2021 model code. That hasn't been removed by Chicago Amendment, so you can follow ASHRAE, or they've added in the Passive House and the Green Building Standards compliance paths. Since new buildings need to be solar ready due to Transformation Code, what defines a building being solar ready? We'll get to that.
Yep, we are just about to get there. Okay, looks like pretty much everybody has answered the poll here. I'm going to go ahead and end it. So it looks like pretty much everybody got the first question correct. Balconies and parapets are both required to have thermal breaks or continuous insulation within the 2022 transformation code. And then again, it looks like pretty much everybody got the second question right as well, that the east and west glazing needs to have about a 20% improvement over the base code minimum requirements. Stop sharing here, and then I will hand it back off to Sean here to continue talking about the commercial requirements.
Okay, we had a couple of questions come into the chat as well I wanted to address. One person asked for that 1 square foot thermal bridge at balconies and parapets, is there a limit on how many can happen at each balcony? There isn't any language limiting the number of penetrations, although we would state that following the installation practices will limit those just as a matter of course. You don't want to go through and put in a whole bunch more extra structural support than you need, because then you're wasting money on those excess materials. So it's mainly putting a limit on the size of those penetrations through the thermal barrier, or say you're using an I-beam or a structural member, your insulation must conform around the webbing so you don't leave a big hole there or something through that thermal bridging. So that's the intent of that 1 square foot thermal bridge limitation. The number of them will be limited by your standard construction practices. The second question was, are there any new thermal bridging requirements that would apply to precast concrete walls, as those typically have difficulty meeting U value requirements? There are not. They would follow the mass wall insulation requirements in the tables. Those tables align with the 2021 IECC. They haven't been made any more stringent in the transformation code. So as long as the assembly U factor meets the U factor table, or the installed continuous insulation R value meets that mass wall R value requirement, those are compliant. And so we will move on now to the discussion of solar ready requirements. So these are all contained in the section 600 added to the transformation code. Section C603 applies to, describes where solar ready roofs need to be applied. New construction buildings and additions larger than 7,500 square feet and less than 60 feet tall. So what we're looking at here is, if a building is like a skyscraper and you make that roof solar ready, the solar panels aren't going to be, there's not enough install area there to offset a significant portion of the building's electric loads. So they've got this height limitation on it because that's kind of what makes sense for offsetting the building's loads in a significant amount with the solar panels, so that they're cost effective. And then again, smaller buildings too, smaller panels, it comes back to a cost parity thing where smaller systems are a higher unit cost per panel to install than larger systems where economies of scale can benefit. So that's where these kind of limitations come in, where you're looking at larger buildings, but not as tall. Some exceptions that apply to solar readiness, buildings that have permanently installed on-site renewable systems already. You've got renewables on site, you don't need to install more renewables. If your roof is shaded by structures or vegetation, more than 50% of the daylight hours, you're not going to produce enough solar energy from PV panels on the roof, so you don't need to bother with making it solar ready. A roof with insufficient solar radiation available, this kind of goes back to the previous point. If you've got shading impacting the building, other structures around you, the way the roof is constructed, if you've got a high slope roof and it's sloped to the north, you're not going to get a whole lot of solar benefit out of that roof. And so solar readiness doesn't really apply there. Roofs with extensive rooftop equipment, skylights, occupiable rooftop areas, rooftop gardens, things like that. If you can't put the solar panels on the roof, then you don't need to make the roof solar ready because you've got other stuff there. And then group H occupancies are also accepted. So looking at the solar ready zone areas, how do we define a solar ready zone? It's the available roof area on a horizontally projected gross roof area less any areas covered by other rooftop equipment like skylights, helipads, rooftop equipment, vegetative roof areas, things like that. And have mandatory access or setback areas as required by Section 1204 of the Chicago Fire Prevention Code. So 40% of the available roof area must be made solar ready. Looking at either a single large area of the roof or a number of separate subzones that total up to that 40% available area. Again, that narrowest dimension between subzones should not be less than 5 feet. That provides your access pathways, things like that. If your available roof area is less than 2,000 square feet, again, you're not going to have an adequate amount of solar installed on that roof to offset building loads and be cost effective. And so there is an exception for roofs that have minimal available area. Again, things that are going to be kind of limiting that available rooftop area: skylights, rooftop parking or helipads, occupiable vegetative roofs, rooftop gardens, mandatory access or setback areas. And what we want to see for that solar readiness is that that area of the roof is going to be indicated on the plans as these are the solar ready zones. This is how you're going to indicate your code compliance with the transformation code. Some additional requirements for solar ready roofs. Solar ready zone shall be free from obstructions such as pipes, vents, HVAC equipment, skylights, roof mounted equipment. You want a clear roof space where it's able to just install the panels quickly. It's readily available. That's why it's considered solar ready. Rooftop loads must be documented and designed for the additional dead load of the panels on the building. So adding an additional 5 pounds per square foot or more in dead load allowance to the construction, again, makes that roof structurally prepared to accept those panels and have them installed. And then in the construction documents, you'll have to indicate pathways for future conduit or piping or design in empty conduit or whatever, so that those areas are ready for solar panels to be installed and have all the electrical components wired in and connected properly. And they don't have to have redesign of the building, moving things around in order to install that equipment. We want these solar ready so that they're easy to install. It's minimizing that future cost of installing this equipment when the building occupants and owners are ready to install these panels. As far as inside the building, if you're going to have energy storage systems for your structure, you're going to need an energy storage system ready area, minimum of 2 foot by 4 foot clear floor area for future energy storage. Again, fire prevention code is going to have some impact there, so refer to the appropriate sections as far as where to locate those energy storage systems. For electrical service, you need to reserve space to put in the panels, circuitry, switch gears, all that that's related to using those solar panels. So you need to reserve space for the dual pole breakers for future solar system and energy storage systems, and label them appropriately so that, say you add some more equipment to the building, those empty slots aren't taken up and now you're not solar ready anymore. And then a permanent certificate needs to be installed indicating how the building has been made solar ready and documenting, near the electrical panel or other approved location, these things have been installed to make the building ready for solar applications. Moving into electrification ready residences in commercial buildings. So when looking at group R2 occupancy dwelling units, rooms and spaces within with domestic cooking appliances shared by the occupants of more than one dwelling unit. This applies to new construction and if you're changing occupancy. It does not apply to alterations, additions, repairs, or changes where the occupancy is staying the same. So if it's already a residential space that was not previously solar ready, if you do an alteration in that space, you don't have to then make it solar ready. We recommend it, but you don't have to. There's additional costs and stuff there. If the occupancy is changing from another occupancy class to a residential classification, then you do have to do these electrification readiness preparation. So ready circuits have to be installed, individual branch circuits labeled spare at both ends of unused conductors, be electrically isolated The space shall be reserved in the electrical panel in which the branch circuit originates for installation of overcurrent devices. The capacity of circuits required by C406 must be included in load calculations for the original installation. So if you have gas equipment in place, but you're installing this electrification ready stuff, you have to make sure that the panel itself is set up to handle those additional electric loads when the conversion is eventually made. Things that are going to need to be electrification ready: indoor cooking appliances. So if you've got a gas stove or something going in to a new construction or change of occupancy space, it also needs to have a 40 amp receptacle within 3 feet of that gas fired appliance to accept conversion to an electric cooktop and oven system. Clothes dryers needs to have a 30 amp receptacle within 3 feet, and water heaters need to have a 30 amp receptacle within 3 feet. So again, running these back to your panel, the panel needs to have a spare circuit there that's labeled, isn't going to be taken up by other equipment or other purposes. Needs to have the proper overcurrent devices, and the panel needs to be properly sized to handle those future electric loads. Looking at residential buildings specifically, solar ready roofs are required for residential buildings. So this applies to new construction residential buildings with more than 3 stories above grade and low slope roofs. So we're looking at 4-story buildings in Chicago. To have a ground level footprint of 7,500 square feet or more are going to need to also have solar ready roofs if they're a low slope roof. So an example at the bottom of the page here, we've highlighted in yellow buildings that might meet that requirement. For residential buildings that are less than 7,500 square feet, again, there's an exception for those. Again, looking at economies of scale application to these buildings to install panels. They can be converted and have solar added by the individual owners of those buildings later, but only greater than 7,500 square feet will need them for new construction. And then on the right side of the screen there is the Stuyvesant town in New York. It's just an example of residential buildings in New York. These are qualified under the residential classification for them. Again, for Chicago, it's going to apply to 4-story buildings that are classified as residential buildings. We touched on this earlier. Gas lighting, new gas lighting is prohibited. Again, as we noted, gas fixtures create a lot of excess waste heat. There's the fumes that come off of those that waste a lot of energy to use gas for lighting, and the gas lighting itself, well, it's a nice ambience, isn't really great quality lighting. And so banning those from future installation, making sure that we're going with higher efficiency lighting and better quality lighting so that we're using it for the purpose it's intended for outdoor illumination. At the roof, looking at solar roof reflectance requirements, roof coverings shall comply with section 1515 of the Chicago Building Code. In that section, it states that low slope roofs should have a reflectance, aged reflectance of 0.72. Other roofs, other than low slope roofs, need to have an age reflectance of 0.15 or greater for both of those. Exceptions to these reflectance requirements, areas that have walking surfaces for occupiable roofs, vegetative roofs and roof gardens, landscaped roofs, and places where you've got solar equipment, photovoltaic and solar thermal equipment. But these requirements are going to help offset that heat island effect for roofing. That's why Chicago's brought them back into the IECC. So looking at the specific low slope roof requirements, as I noted before, an initial reflectance value of 0.72 or 3-year installed reflectance value of 0.5 or greater. Sorry, I got that mixed up earlier. Exceptions include where more than 50% of the roof area is vegetative roof or roof garden. The remaining roof area is allowed to have a 3-year installed reflectance of 0.3 or greater instead of the 0.5 or greater. Roofs with a minimum 15 pound per square foot of ballast installed over the entire roof area shall again have that minimum of 0.3 reflectance, that 3-year aged reflectance. So some allowances there for different styles of roofing types and allowing for that reflectance to be adjusted downward when there's other means of offsetting that heat island effect from those flat roof areas. Looking at sloped roofs and residential type structures, roof coverings other than low slope roofs shall have an initial reflectance value of 0.15 or greater. Roof coverings with a slope greater than 5 and 12 at 41% slope are accepted in historic buildings. If you can't find an adequate reflectance material, you want to still maintain that historic appearance for those structures. They are accepted from these requirements as well. Electric vehicle supply equipment is required to be installed or ready at parking spaces in accordance with the Chicago zoning ordinance 1011. So this is essentially stating that for 50% of this, or sorry, 20% of spaces at new construction facilities with a minimum of at least one space needs to be electric vehicle supply equipment ready or installed. So multi-unit residential with 5 or more units on site needs to meet that 20%. 20% of 5 is 1, so you need to have at least one space or more that are EVSE ready. New construction for uses other than residential with 30 or more parking spaces then need to have at least 20% of the spaces EVSE ready or installed. We've had a few questions in the past about whether this applies to different types of spaces regarding passenger cars, tractor trailers, box trucks, fleet vehicles, things like that. The type of space isn't specified in that zoning ordinance. And so you count up the total number of spaces regardless of their usage. 20% of those need to be EVSE ready or EVSE installed. Lighting for plant growth. Many people are probably familiar with this addition. It's proposed for the 2021 IECC, but makes the energy efficacy of plant lighting a little bit more stringent than what's in the IECC. States all permanent installed luminaires shall have a photon efficiency of not less than 1.7 micromoles per joule for greenhouses and 2.2 micromoles per joule for all other indoor growing spaces. There is an exception here for buildings with no more than 40 kilowatts of aggregate horticultural lighting and cannabis facilities subject to the Illinois codes there. So again, growing facilities, that supplemental lighting to grow plants and stuff is largely energy intensive, making that as efficient as possible so that the intended purpose of that light, delivering photons to the plants for their purposes of their growth, is what that lighting is serving. I believe that brings us up to our next poll question. So we'll go ahead and launch that. Our first question: for solar ready roofs are triggered by what roof area in section 603? Is it 2,000 square feet, 4,000 square feet, 7,500 square feet, or 10,000 square feet? And then for the 2022 transformation code, electrification requirements ban gas appliances. Is that true or false? Let's see, we had something come into the Q&A. Will EVSE requirement apply to public parking in retail uses? I don't recall that there's an exception to building use classification as far as parking spaces. So I would believe that EVSE ready still needs to be there for retail uses as well.
I believe that's correct, yes. And then we did get a question in the chat. It looks like the electrical service has to be sized for a multi-unit building. I'm guessing that's going back to the electrification ready question about the required electrification ready circuits being included within the building's electrical service load. And if I'm understanding that question correctly, yes, if it was a multi-unit building, the electrification ready circuits still have to be included within the base electrical load design load for the building. Doesn't matter if it's a multi-unit building or not.
Looks like most of our poll responses are in, so we'll share those results. So our first question, solar ready roofs triggered by what roof area? 7,500 square foot also is the building area that applies there. Looks like most people got that correct. And then electrification requirements ban gas appliances. That is not true. You can still install gas appliances, but you have to have the electrification ready circuitry and outlets nearby those gas appliances so that it can be converted to electric later. It's not a gas ban. It's just an electrification readiness requirement. Yep. I will turn it back over to Robert to go over the residential sections.
All right, thank you, Sean. We'll keep moving along here. All right, so the first thing we're going to touch on here within the residential requirements of the transformation code are the additional energy efficiency requirements. So first off, since the transformation code is allowing for certification through either Passive House Institute or National Green Building Standards, if you choose either of those pathways for your project and your project is certified under either of those pathways, there are no further compliance requirements for your project. So you do not need to select and implement any additional energy efficiency packages. If your project is following the prescriptive or total building performance compliance paths, you do need to select 2 additional efficiency package options and implement them within your design. This is a change just to be aware of from the 2021 IECC. The 2021 IECC only requires 1 additional efficiency package, whereas the Chicago Transformation Code is requiring 2. So that is just something to be aware of, especially if you do projects both inside and outside of Chicago and elsewhere in the state, that requirement for additional energy efficiency packages is different in Chicago than it may be in the rest of the state when we get our state energy code adopted here in the summer. Let's keep moving on here. Again, we've pulled out the table. This is the maximum assembly U factors table. So this is table R402.1.2. That top row there shows the original 2019 Chicago Energy Conservation Code values. And then the row below shows the new updated 2022 Chicago Transformation Code requirements. Again, we've highlighted where those requirements have been updated since the last code cycle. So those highlights there in green with bold lettering, those are where you have increased U factor requirements. And then we also have highlighted there one of the only instances really where the Chicago Energy Code has added additional requirements into these tables on top of and above the 2021 IECC is that the Chicago Energy Transformation Code has added in fenestration solar heat gain coefficient requirements within climate zone 5. Moving on to the R value table. So one change just to cover that real quick is that the 2021 IECC has changed the order of these 2 tables and has now put the U factor table before the R value table. The Chicago Energy Transformation Code has kept that arrangement. The main reason for this arrangement is that the U factor table allows for a little bit more flexibility, innovation, using non-traditional assemblies or allows for a little bit more flexibility in design. And so that way they put that table first to, in some ways, encourage innovation and new designs. And then they put the R value table second. There's no real change in the requirements. It's just a shift of which table is shown first. You can still comply with either table. It's just the order has changed. So here again, we are highlighting the differences between the 2019 Chicago Conservation Code and the 2022 Chicago Transformation Code. Highlighted boxes there show the improved or increased requirements. Again, there is the solar heat gain coefficient requirement for fenestration added there. Again, that is above and beyond the 2021 IECC. Another note here, kind of talking more towards building science again, is that there is a note within the code that the assembly of 20 R20 cavity plus 5 continuous insulation, there is a risk of condensation within that assembly, and this has been determined based off of Passive House Institute modeling and testing, and Passive House Institute has also proposed a state amendment to include this within the state code, or to include this note within the state code, and the aim of that note is to ensure that cavity insulation shall not be less than 0.3. The ratio of continuous to cavity insulation shall not be less than 0.3. If you want to go lower than that ratio, you really should do a hydrothermal analysis, especially up in climate zone 5. The idea here is that we really want to keep the inner face of any exterior sheathing warm enough to prevent condensation. If you do not have enough continuous insulation on the exterior face of that sheathing, the interior side of that sheathing could still become cold enough that if any interior conditioned air makes it through the wall assembly and meets that cold interior sheathing surface, it could condense and cause water issues. And nobody wants water issues in their building. Obviously, water issues within an exterior wall at the interface of the sheathing may be hard to notice for some time. So the consequences of this, of getting this wrong, may not pop up right away. So again, it's just a cautionary note to designers there, that especially in climate zone 5, that continuous insulation is really pretty important in terms of keeping your exterior sheathing free from condensation and moisture risk. So moving on to specific roof insulation requirements. So this is section R402.2.2. Real quick, going to talk about the 2021 IECC and then how that differs from the Chicago Transformation Code, because there's a bit of a difference here. So the 2021 IECC sets a minimum insulation requirement for ceilings without attics, and they have an allowance that allows R30 to be installed within vaulted or narrow frame ceiling spaces where the full required insulation value is, you can't fit it for whatever reason due to the design of the assembly. That's limited to 500 square feet or 20% of the ceiling. So those requirements are in the 2021 IECC. In the 2022 Chicago Energy Transformation Code, that allowance does not exist. So that means that all framed ceiling assemblies must have R6 insulation as a minimum. So this either requires thicker framing or pushes designs towards more continuous insulation. As we've said a couple of times during the presentation today, really the codes are really driving more and more towards continuous insulation. There's a lot of building science benefits about getting that insulation plane on the outside of your framing. It prevents thermal bridging, which is another thing that we've talked about. And so this is another instance of the code really doubling down on that idea of trying to push towards more continuous insulation. Moving from sloped roofs to low slope roofs, the 2022 Chicago Transformation Code has replaced the minimum insulation requirement of R60 with R42. Now this is only for low slope roofs. And for this to apply, the insulation must be continuous above the deck and must cover 100% of the roof area. So again, that's only for low slope roof applications, not for sloped framed roofs, but for low sloped roofs, the minimum insulation requirement of R60 is not required if you have insulation continuous above the deck and 100% roof area coverage, you can reduce that to R42. Okay, so again, talking about steel framed assemblies, as I just mentioned, thermal bridging is something that the code is really trying to target and eliminate or reduce as much as possible. So very similar to the commercial requirements we mentioned earlier. The transformation code requires residential steel framed assemblies to also determine their U factor of exterior assemblies using the S250 formulas. So these requirements are very similar to the commercial requirements above, pretty much the exact same. All exterior continuous insulation can be any framing distance. So if you're using only continuous insulation, your framing can be whatever spacing on center you want it to be. If you are spacing your steel framing at 16 or 24 inches on center, you would use the next lower framing member spacing input within the S250 calculations. So as we showed for the commercial requirements, you just drop that spacing measure down in the table and you use those the next spacing downs requirements rather than sticking with 16 or 24. Then larger spacings than 16 or 24 must use the S250 formulas to calculate without any other modifications. So you just follow the S250 formulas if you have larger spacings than 16 and 24. And again, for custom framing members or non-typical members or non-C-shaped members, you would follow the S250 formulas for those non-standard or custom framing members. A little bit more about steel framed assemblies. So table R402.2.6 from the 2021 IECC is included within the transformation code as well. They've removed references to the type of the assembly, and they only use requirements or only show requirements for 16 inches and 24 inches on center framing with greater than 30% continuous insulation. Cavity insulation ratio. So again, that kind of goes back to the warning there from the Passive House Institute. Although this is talking specifically about steel framed assemblies, there still is that ratio of insulation applies in this instance as well. And I would say that the risk of condensation is the same no matter what type of studs you're using, and the effects of thermal bridging will be much greater with a steel stud assembly over a wood assembly. So again, something to keep in mind there. Again, talking about parapets and balconies within residential buildings. So the commercial requirement to either continuously wrap those assemblies with insulation or provide a minimum R3 thermal break also applies to residential buildings. And again, this would refer you back to R605, and also the exception for structural elements applies just the same in residential buildings as well. So again, that exception, we've kind of covered this already, but that's a 1 square foot exception for structural elements, structural beams, post tension cables, anything along those lines that needs to extend through the thermal envelope out to support the balcony. Each one of those openings can be a maximum of 1 square foot. Okay, a little bit here about duct leakage exceptions that have been added. So these exceptions have been added for different tests. So there's the rough-in test, the pre-construction test, and then also the testing of ducts within thermal envelopes. So the new requirements here, or the new pieces here, are the exceptions that have been added, and essentially what these exceptions provide is a minimum airflow for very small duct systems. So these would be duct systems that the typical code language just simply doesn't apply to, or is not cost effective to enforce the full requirements on. If your duct system size is below these thresholds given by these exceptions, and if you can only achieve 60 square foot, or sorry, 60 CFM of leakage or less, then it complies with the Chicago Energy Transformation Code. So these exceptions here kind of account for small or unconventional systems that may not align with the typical code language or typical duct systems. And again, that is if a duct system can achieve only 60 CFM of leakage or less and meets these size limitations, then it complies with the transformation code. Moving on to whole house ventilation fan efficacy. So the Chicago Energy Transformation Code includes a section for range hoods. This, if you've looked at the 2021 IECC, the first printing, or I believe even maybe the second printing, this section on range hoods is not in the 2021 IECC. The Chicago Energy Transformation Code has put the range hood section for range hood requirements back in, but the IECC has also done that as well. The most recent errata for the 2021 IECC also adds this range hood category and requirements back into this table. So the Chicago Energy Transformation Code and the IECC, the 2021 IECC, are in alignment on this requirement. It was a mistake made in the original printing of the 2021 IECC. So both codes are in line, and both codes have specific requirements for range hoods that differ from the other system types listed here in the table. So HRVs, ERVs, or balance systems, those have their own requirements, as well as inline supply or exhaust fan systems. Those have their own requirements. And then any other exhaust fans, either greater than or less than 90 CFM, have their own requirements as well. And then listed there at the bottom is air handlers integrated to tested and listed HVAC equipment also has their own requirements. They're listed in the table. So just keep in mind here that both the Chicago Energy Transformation Code and the IECC are in alignment on this requirement. You just need to make sure that you're looking at the most recent errata for the 2021 IECC. And then talking a little bit here about local exhaust and exhaust discharge within residences. So this is section R403.6.4 and 0.5 here. So these are additional requirements added to the Chicago Energy Transformation Code. The first requirement here was contained within the mechanical code and has been ported over to the energy code for a little bit more clarity while designing, so that the codes are in closer alignment with each other. And this provides table 403.6.4 here, where minimum required local exhaust rates for kitchens must be 100 CFM if it is installed to be an intermittent exhaust, or 50 CFM if it is installed to be a continuous exhaust. And then for bathrooms and toilet rooms, the exhaust requirements are 50 CFM for intermittent systems, or 20 CFM for continuous systems. And then moving on to R403.6.5, exhaust discharge the exhaust must discharge outside the envelope on the building. It cannot be discharged into the attic or the crawl space, and it cannot be discharged near a ventilation intake. Now, this is, in some ways, this really is common sense. You wouldn't want to put your exhaust right next to a building intake anyway, but this code here is, the code requirement is going to ensure that that doesn't happen. There are exceptions to the R403.6.5 for whole house fans within private dwellings or kitchen range hoods. Those are the only two systems that are exempted from that requirement there. Then moving on here, so ventilation design. So a few more details on ventilation design within residential buildings in the Chicago Transformation Code. So required ventilation rates can be reduced by 30% if supply air is ducted to all of the bedrooms within the unit and at least one of the living room, dining room, or kitchen. For this to apply, for you to be, for your ventilation system to be reduced by 30%, this must be a balanced supply and exhaust system. So again, if you would like to lower your ventilation requirements within the unit, one way to do that is to make sure that supply air is ducted directly to all of the bedrooms and then at least one of the other living spaces, so the living room, dining room, or kitchen. The intent behind this here is to provide conditioned air where it is needed most. So where there are the most occupants, or where occupants may spend the most time. So providing bedrooms where people are sleeping, providing fresh air into those spaces, and then providing fresh air into at least one of the other gathering spaces. We're trying to provide air where people are, not just providing air through the building for the sake of meeting the code, but trying to provide air directly to where it's needed to the occupants. And then again, another section here that's been ported over from the mechanical code for more clarity. That formula there is the base formula that you would use in order to determine if your system can, or that's how you would determine if your system, how to make it an intermittent system rather than a constant system. So you would get your CFM rate, and that equals 0.03 times your conditioned floor area plus 7.5 times the number of bedrooms plus 1. So you can operate for an exhaust system to operate intermittently. The ventilation rate must be scaled up by the factors in the table shown there at the bottom, based on the percentage of every 4 hours the system is in operation. There is also, so the base formula there accounts for essentially, 2 occupants within a master bedroom, and then 1 occupant per other bedroom besides that. If your residential unit has more occupants than that, and you're aware of that in the design phase, there is an allowance that ventilation can be increased for higher occupant densities than 2 plus 1, and that essentially is done by just adding another 7.5 CFM per additional occupant. And then there is a requirement for ventilation testing and verification of airflow rates for whole home ventilation systems added within the code as well. This is a little bit different than if you're familiar with the 2021 IECC individual fan testing requirements. This is a little bit different than that. Okay, and then continuing on here, how do we demonstrate compliance, or how do we how do we demonstrate compliance for our projects within the Chicago Energy Transformation Code? First, we'll continue on with residential buildings a little bit here. So the first thing to understand is the definition of a residential building within the Chicago Energy Transformation Code. So the code defines a residential building as a detached one-family dwelling, or any building that has 4 or fewer stories above grade plane and contains multiple units in which occupants reside on a primarily permanent basis. So as I mentioned near the beginning of the presentation, a residential building within the Chicago Energy Transformation Code is essentially a building that is 4 stories or fewer that has non-transient residential units within it. Key point to remember here at the bottom is that if a residential building, so a building that's 4 stories or less, contains non-residential uses, so if it's a mixed use building with both commercial and residential portions to it, a commercial compliance statement must also be submitted with your project documentation. And so talking about the compliance statements, so a residential compliance statement must be submitted, must be filled out by the licensed professional for the project. So that'd be a licensed architect or engineer, and this must be submitted with every application to construct or alter a residential building. And so just to touch a little bit more on the residential building definition, that includes anything ranging from a townhouse, row house, apartment house, convent, monastery, fraternity, sorority house, or student dormitory, or a rooming house. So again, that's 4 stories or less with non-transient residential. Looking at the compliance statement here, we can see after the initial section up at the top, the lower section there is the compliance method. And so we've pulled those choices over off to the left there. So when you're filling out this form, you simply check which compliance method your project is aiming to follow, either through ResCheck, which is recommended because it makes it easier to get through the process. As the verification process is easier, a little bit quicker and easier through ResCheck. You can also follow the prescriptive path, total building performance path, energy rating index, or as we mentioned previously, the Passive House Institute certification or National Green Building Standards certification. All of those are applicable compliance methods for the residential compliance to the Chicago Transformation Code. So moving on back to commercial buildings. So again, we mentioned this at the beginning of the presentation, but the definition of a commercial building within the Chicago Energy Transformation Code is anything that is not a residential building. So anything that is greater than 4 stories, or anything that is less than 4 stories and doesn't contain non-transient residential. And again, if a mixed occupancy building contains both non-residential occupancy and residential occupancy that is up to 4 stories, you must submit both a residential and commercial compliance form. If you have a mixed-use building that is greater than 4 stories, that building is a commercial building, and so then you would only have to submit a commercial compliance form. And then here's what the commercial compliance form looks like. And again, we've pulled out the different compliance methods there towards the left. There's a few more options here for the commercial side than the residential side. So we have, again, ComCheck. We have the IECC prescriptive path, the IECC total building performance method. And then you do have your options, as somebody asked earlier, we do have the options to follow ASHRAE 90.1, prescriptive path, energy cost budget path, or performance rating method. And then again, you have your Passive House Institute and National Green Building Standards certifications as well. And then just to talk a little bit about the above code buildings, so the Passive House Institute and National Green Building Standards. So Passive House Institute, this specifically is the Passive House Institute US. Passive House has been a design standard for quite some time now. It originated in Europe, and the Passive House US is the organization that creates documents and assists in project development and project verification and even project design. If you have a project or a client who wishes to pursue Passive House Institute certification, you would start with the 2021 Passive Building Standard Certifications Guidebook. Version 3.1 is, I believe, the current version. Within that guidebook, there are 2 primary paths. There is the Passive House Institute Core path, and then the Passive House Institute Zero path. Now, the Zero path is essentially getting your building to net zero, whereas the Core path just takes the core principles of the Passive House Building Standard and applies them to your project. And again, this certification method and compliance path is applicable to both commercial and residential. And just a quick look at maybe how Passive House Institute projects stack up against other building standards or other code standards. This chart is a little bit dated here, but we have a little bit of additional information off to the left there, so we can clearly see that Passive House certification is far, far to the right. The third column to the right there is the Zero Energy Ready Homes, which is a U.S. Department of Energy program. And then we have 2 columns there for Energy Star, depending on the version. And then the last column is the IECC from the 2012. Now, if we were to update that towards the 2021 IECC, you can see off to the left there that the IECC Home Energy Performance Index for Climate Zone 5 is 55. Now, that value is not exactly the same as a HERS rating. There is a little bit of a difference between those 2, but you could see that 2021 IECC residential building would probably land somewhere around the 2 Energy Star columns in reference to a Passive House building. And then lastly, really quickly, just to talk just a little bit more about this. So the National Green Building Standard certification to comply with the Chicago Energy Transformation Code, your project can pursue either the gold or emerald level certifications. Either of those comply with the code completely. And we also have a chart here, something somewhat like the Passive House Institute chart that shows National Green Building Standards certification efficiency improvement over a 1975 baseline in comparison with ASHRAE 90.1 commercial and the 2021 IECC residential. So you can see it's quite a bit more efficient than the IECC residential, and then it does lag a little bit behind the ASHRAE 90.1 commercial there. At this point, I think we have our last poll question. And so the last two poll questions here are number one, which residential amendment to the Chicago Energy Transformation Code is the only potential weakening amendment? Your choices there are vaulted ceiling insulation requirements, duct leakage testing exceptions, steel framed wall R-value adjustments, or local exhaust ventilation requirements. Then the second question is how much can whole house ventilation be reduced if supply air is sent to just the bedrooms? And your choices for the second question are can't be reduced, must meet IRC, IMC ventilation requirements, 10%, 30%, or 50%.
Well, questions came in looking at the residential additional efficiency package options where the transformation code requires 2 of those to be picked. The 2021 requires 1. That does apply to new construction only. It does not apply to existing buildings. And then as far as the slides, these should be uploaded to our website by tomorrow, I believe, and you should be able to access them from our website. We did have a question here about looking at roof replacements on commercial buildings. Does the parapet insulation need to be improved to have that thermal break when you're doing roof repairs or roof upgrades? The parapet is part of the wall assembly, not the roof assembly. And so the parapet itself does not need to be upgraded when you're doing upgrades to the roofing itself. There are separate building systems. So we talk a lot in our presentations about limitations for existing buildings. Existing constraints can limit how much insulation you can improve. So you don't have to meet the energy code requirements. Parapet height still applies to that. You don't have to update the parapet and increase your roofing insulation level.
I think you got a little problem with your mic, Sean.
Oh, set high on my face. That's why. So just to cover those again real quick. For the residential additional efficiency package options, those do apply to new construction only. For get this. Not what I wanted to do. Slides are available on our website by tomorrow. They should be on our webpage where you can download these slides and access them. When you're doing a roof replacement or upgrade project, the parapet is considered part of the wall assembly. You don't have to upgrade the parapet with the thermal breaks or additional insulation when you're doing roof repairs, roof upgrades, roof alterations. Go ahead and share our poll results. It looks like most people have those in. So for question 1, the only potential weakening amendment is the duct leakage testing exceptions because the energy code doesn't have that floor of 60 CFM for duct testing. That's only applied to the transformation code. What they're trying to account for there is the smaller the duct system gets, the tighter and tighter you have to make it to achieve those lower ventilation requirements. And at some point, you hit a kind of a feasibility mark where you just can't make it any tighter than it is. And then for how much can whole house ventilation be reduced if suppliers sent to just the bedrooms? It can't. It has to be the bedrooms plus one other space, and then you get that 30%. If it's just the bedrooms, then you still have to meet that full ventilation requirement. So a little bit of a trick question there. Looks like we split you guys a bit. If it was the bedrooms and one of the other living spaces, the kitchen, the living room, the dining room, then that 30% would apply. Since it was just the bedrooms in this question, we kind of tricked you a bit there. Don't like that it keeps doing that when I click on an inactive screen. Couple more things that have come in through the chat, looks
Yeah.
like.
Yeah, there's the residential roof question there.
Yeah, if converting an unconditioned attic to a conditioned attic space with minimum dormers, does the entire roof of conditioned space need to have the R60 roof insulation? So that kind of comes to that attic was an unconditioned space, and now you're conditioning it. That's a kind of a change of use for that space, and so full energy code compliance applies to that space. So yes, it would be that R60 requirement that we talked about earlier. And then I'll stop doing that. I've got screens on top of the presentation, and it keeps clicking on the presentation instead of my active screens.
The
looks like the
top
chat
question. Yeah, I think we're done with the chat question there. The top question, the question and answer for additional energy requirements in C406 are 2 additional compliance pathways needed even if one exceeds the 10-point requirement, or can one path be selected as long as it equals 10 points or more? The language within the Chicago Energy Transformation Code does not reference the points. It just simply states that 2 options must be selected. So the point requirements there, that applies only to the 2021 IECC and not the 2022 Chicago Energy Transformation Code.
That's confusing the commercial and the residential requirements.
Yep.
The residential, you just have to pick 2. There aren't
Right,
points associated
right,
with them.
right.
For the commercial, it's the 10 points, and it's just the 10 points. That's unmodified in the transformation code.
Right. Thank you for that correction.
Is there a person to contact or official procedure to get a technical infeasibility or other energy code variants for existing buildings? We're happy to help with questions. Your code official is probably going to be the person you're going to lean on most there when you're looking at issues with meeting the prescriptive requirements of the code. But again, the code language itself has built into it a lot of times those exceptions where it's not a non-compliant issue to have lesser insulation if there's a danger to the building structural integrity, health and safety. There's other existing constraints. That language is built into the codes already in the existing building section. So we can help you understand those. If you have a specific question, please do reach out to us and we can help you with that. Under R403.6.7, if mechanically ventilated, does this now negate the requirement for natural ventilation in Chicago? So I don't know that there's a requirement for natural ventilation. There are probably ventilation options to allow for natural ventilation. But for most buildings, even with natural ventilation designs, you may want to supplement with mechanical ventilation that meets those mechanical code requirements. We would have to look into that and get back to you on that particular question.
There may have been an old requirement for natural ventilation, but yeah, we can check in on that.
Similarly, on like, do windows change the ventilation requirements? No. If you've got operable windows in a residential building, you still have to have that mechanical ventilation because there are times of the year when you're not going to want those windows open and you're conditioning the inside of that building, like the dead of winter when it's -10 degrees outside. You still need to have proper ventilation under those conditions. So your mechanical ventilation does still need to be in place. So no, windows would not affect that requirement. Okay, I've got to find a solution for this. Let's try that. Is EGC not a valid certification for compliance for residential? I'm not sure what EGC is. If you can send us what that acronym stands for. But what's detailed in the Chicago Energy Transformation Code is compliance through the IECC pathway, ASHRAE, Passive House, and the National Green Building Standards. There isn't another standard listed, although there is, I believe, language for other approved standards. So it would probably come down to whether that would be approved or not as something that's beyond or equivalent to the energy code.
Yeah. Enterprise green communities. Yeah, that is not specifically listed
Okay.
within the code.
Does a high-rise building interior renovation require an energy compliance statement? Yes. So any permitted work in a building, you're going to have to do an energy code compliance form to document that you're going to be meeting the energy code requirements. So the Chicago Building Department forms we showed on the slides earlier will be submitted with a project, and then whatever documentation for your chosen compliance pathway, whether that's a ComCheck report, building energy model reports, a prescriptive code checklist, those things would have to be documented, yes. As far as an energy certificate, like the panel certificate that goes in on the electrical panel for new construction buildings, that is not required for existing buildings. Although we will say that it's probably a good idea to document those changes and updates so that future building owners know what's installed in that building. And then one last question in the Q&A here, would the transformation code apply to total renovations of an existing residential building, like a 6-flat, less than 4 stories? The project is an interior gut to the existing masonry. So it's an existing building, but you're modifying almost all the systems in it. And so some of the existing building requirements apply there. It depends on what specific assemblies and things are in place there. But like if you have mass walls in the building, you're not opening up cavities. You don't have to add additional insulation to the walls, although we will say it's a very good idea. The attic space, again, if you're opening up a cavity to like a vaulted ceiling or a low slope roof that has insulated ceiling cavities, those opened cavities would have to be filled with insulation to be in compliance. If it's above deck insulation, then you're going to have to insulate that to as much as possible, given any existing constraints from parapet walls, flashing heights, things like that that are on the roof exterior. Lighting, electrical, all that stuff would then also apply since it's a full gut rehab. So you're touching all the electrical systems, all the mechanical systems, all those would have to be then in full compliance with the code.
And then real quickly, we did get confirmation from another team member that the old requirement for natural ventilation that was in the previous code has been removed in this update.
Okay, thank you. That's all we have. I don't see anything else in the Q&A. Let's see. Nothing else is coming to the chat. So we have to thank everyone for joining us today. I hope it's been a helpful presentation for you. If you do have any questions, please reach out to us, energycode@illinois.edu. We hope you have a wonderful afternoon.